I just want to prepare this video to help you to understand better about your first homework, especially the first time we meet in the first class. I kind of briefly review about the mathematics that we frequently use for this course. That's why, especially for this first course, I prepared this video to help you finish up the homeworks, especially for mathematics or derivatives. So first, we just solve together from the questions in the first homework. The first one is that we need to find the derivatives of this one. Okay, so let me see your homeworks. So number one. So r function of theta is equal to 0.4 and cosec theta. So I want to find dr over dt. Okay? That's our first question. So right now, and then our theta is a function of time, and then I want to find the derivatives of this r function. So right now the problem is that the r function is a function of theta, although we know that the theta is a function of time. But right now we want to take the derivatives of r function with respect to time. So first you need to understand we use the chain rule. Okay. So first I want to take the derivatives of my r with respect to theta, and then take time derivatives from your theta function. So dr over d theta, and then d theta over dt. So this is chain rule. Okay. So let's just move on. So if you take time derivative, not the time derivatives, the theta derivatives for the r function, what is it? So if you just take take derivatives of cosec, that's minus and cotangent theta. Okay. Then we still do the time derivatives of this one for theta. So I just want to write down this one is d theta over dt. So for simplicity, we just represent this one as a theta dot. So that's the same as d theta over dt. So this could be our answer. Okay, then number two. Let's try to find dr. So this is a So second derivatives for the r function. Okay, second derivatives of our r functions. So right now we already found the result from our first derivatives. Okay, so this is for the notations. This is r2 dot. Okay. And likewise, like we used the chain rule, we also want to use the chain rule. And then this is nothing more than take another derivatives from these results. Okay, this is first derivatives result. So we want to take a second derivatives. So we just want to take that derivatives. But likewise, we want to use the chain rule because the r function is a function of theta. Okay, but we want to take a time derivatives. That's why since we know the theta is a function of time, so we want to use the chain rule, which means we want to take theta derivatives for the r functions, then multiply by d theta over dt. And then right now, this results is combinations of multiple theta functions. So we just take care of this one first, and then second one and third one. So let's say we just take care of this one first. So I want to just write down negative 0.4, then b c s c theta over dt, and then cotangents and theta dot plus. Okay. Then I want to take care of the second term. So 0.4 cosec theta and d cotangent dt and theta dots. Then we need to take care of the very last one, cosec cotangent and d theta dot over dt. Okay, so let's just do this one. So we already did this one, right? So we already did this one. So this one, okay, is just exactly the same as so if you just take a time derivatives, not the time derivatives. Let me just write down here. So you can just consider that this one is dc cosec over d theta over d theta over dt. Okay. And then this one, we just use the chain rule. So d cotangent theta over d theta over d theta over dt. And how about this one? So we don't need to use chain rule because right now we know that theta is a function of time. So you can directly get the time derivatives from that third term. So this is directly d theta. So this is theta 2 dot. Okay? So just take care of this one. So we already, what's the result of d cosec theta over d theta. So this is negative. Okay. Then how about this one? So this one is, if I just write down here, this is minus cosec theta squared. Okay. So I just write down this one more nicely. So minus 0.4 and then minus cosec and cotangents, and then I need to write down this one. So this is theta dots and then cotangent theta and theta dots, okay, plus the next one and minus cosec square and then d theta dot and then theta dot here and then minus 0.4 and this is a theta 2 dot, right? So you can make more, you can rearrange this one more nicely. So right now we have a 2 theta dot. You can write down as a theta dot square and this one as well. So you can just simplify it and then just double check whether you get the right answer. Okay? But please just understand that how you apply the chain rule for number 1 and for number 2 questions from our first homeworks. Okay, the next problem is number 3. So we need to evaluate number 3 from 0 to 3 and 20 exponential of. So this is integral, okay, And then, as you know, the very basic integral rule. So I already talked about the very basic formula in the course. So you know that. Let me just write down the formula here. The exponential integral is just the integral of the constant. Okay. So let's just apply that one here. So right now, this is equal to, and then let me just write down one more thing here. So the very basic derivatives rule, which is D and C okay. And then how about this one then? AX. So this one can easily get EAX, and then take another derivatives for this power. So this is A. Okay. Okay. So if you just remember the three very basic formula for integrations or derivatives related to the exponential function, then we can easily get this one. So right now, we just take the 20 out of that integral. Okay. And then, so if you just think about the integrations of exponential 1, and then we know that later minus 0.6 comes out from your exponential function, so this is a reverse way to do it. So that's why I put the minus 20 over 0.6 and integral of 6t through 0 through 3. Okay. So this is equal to so if you just compute this one, you could get the answer. So let me just keep that here, and then just please confirm that your answer is the same as the answer key. Now let me move on number 4. So number 4 is another derivative, deliberations for the tangent function. Okay. So your tangent function is a little bit complex here because it has another sine function in it. So in this way, in this case, you can just substitute this internal parts for another kind of symbol. So let's say let u is 5 minus sine 2t. Okay? So which means this question becomes du over dt. Okay? Because we substitute this part with u. Then right now, oh I'm sorry, not the u. So this is tangent u. Okay? But right now, I want to take a derivatives. I want to take a derivatives of this tangent function with respect to time. But this tangent has only the function of u. Okay, so that's why I want to use another chain rule, which means I want to use tangent u over du, and then du over dt. Okay. So what is the derivatives of tangent u over du? Okay. So it's kind of simple. So if you take a tangent function, you can get the sec function square. So this is sec function square u, and then we still need to take care of the u over dt. Okay, so right now I just replace back for the u and then take a du over dt here. So this is a sec square and 5 minus sine 2t, and then I need to do this one d over dt here. So if you take the derivatives, this constant value will be 0, and this sine is cosine. So this is cosine 2t. And then we have a 2t inside, so we need to I put another 2 at the very last here. So right now, if you look at this one, this du over dt, the result of d over dt is this one. So I hope you understand why we got that answer, because right now we just use another chain rule. So my chain rule is like that. So right now du over dt is equal to d5 over dt minus d sine 2t over dt, right? So as you know that this will be 0 because 5 is constant value. How about this one? So right now we just assume that let's say theta is sine 2t. Okay? We just assume that theta is 2t. Okay? So which means d sine theta and dt, but we just substitute t with the theta. So if you use another chain rule, this is the same as sine theta over d theta over dt. So that's why this is minus cosine theta, and d theta over dt is this one. So 2t over dt is 2. Okay, and then the theta is 2t, so cosine 2t and 2. So that's why d over dt becomes minus cosine 2t times 2. That's why I just write down in here. So I think this is the answer, right? This is the answer. So please understand this kind of process. So right now we use the chain rule twice. The first one we just let the u is the internal part of the tangent, and then we use the chain rule. And then for d over dt, because we have sine 2t here, so that is kind of came in the minus cosine 2t too. But this process also involved in the applications of chain rule. Okay, number 5. Let me just move on to number 5. Number 5. So this is another derivations, but a little bit complex. Okay. Okay, then maybe you can just simply think about that u is square. Okay? So, which means this one is like du square and dt. So, which means du square du over dt. So what is this one? Du square over du, 2u, right? and then d over dt. So let me see. Maybe my question, I'm not sure about your four questions. So this one should be t, the x here. X. Let me say x. And this one is x. Okay. So let me change my notes. This one should be x. Okay. So d over dx is, I just replace this one is 1 over x minus 1 over x squared over dx. And then u is just 2, 1 minus x, 1 over x squared. D and 1 over x. And then how can we get the derivatives from the second term? So x squared. And then you know the derivatives of this one. So let me just remind you the formula here. So let's say we have f over g function, then you want to take the derivatives that f over g function with respect to x, then this one is g squared and f prime minus fg prime. So we just use this one, okay? So here you can simply think about this is f. You can simply think about this is a g. Okay. So if I just apply this formula, so g squared should be your the bottom parts. So I just want to put that g here. So 1 minus x squared, that's the g squared, and f prime. So I need to take the derivatives, that is minus 1, then multiply by 1 minus x2 squared minus f, this is f, and then g prime. So that's the 2x, right? So this is the answer. So if you just simplify or rearrange this one nicely, then you will see the answer key that I provided in your handout. Okay. Then number 6. Number 6 is integration. So this one is 3x minus 2 divided by square root of x squared dx. So let me just write down in this way x 1 over x squared dx, and then 2 1 over x squared dx, right? So we can just, so this one is combinations between these two terms. So we break down our integration into the two parts, and then let u is 1 minus x squared, okay? And then because I want to replace the bottom part with the simpler the term, which is a u here, and then how about the du over dx? So since we define the u is 1 minus x squared, d over dx is minus 2x, right? So from these equations, what do you see? So du over minus 2 is equal to x dx, right? So from here we got this one, because I want to get this one because I want to replace x dx with d over minus 2. Okay, so using this one, we can just a little bit change on this one part. So this is 3, and then I just replace this part here. Okay, so this is square root u, and x dx is equal to minus 2 and du, okay? And plus the other one. Let's look at the second term. But for the second term, this is second term, we can directly use the formula. So in the formula sheets I gave you, in the formula sheet here, so in the formula sheet, let me just write down the formula sheets here. So we can just simply use that one for the second term, but at least for the first term, we just create u, which represents 1 minus x squared, and then just use it. Okay. But let's just do the second term first. So this one we can simply use that one. So this one is 2 sine inverse and x plus a certain constant, okay? And then let's take care of our first term here. So right now, 1 over negative 2 is negative 0.5, right? So if I take that part out, then this one is negative 3 over 2, and then this is u minus 1 over 2. U to the power of half and du, right? So the second term is still the same. So you can just continue to do that. So this is nothing more than 1, 3, and 2. And then this is u So let's return everything back to replace the u. So this is 3 So let me the negative is a mistake, so let me just correct that one. So this is a negative 3, and then the u is 1 minus x squared, number 2, and plus 2 sine minus inverse sine and constant value. So this is the answer. So look at this one. So right now, these equations has the combinations between first and second term. So we just break down our integration into 2, and the second term we can simply use the formula, so which becomes the inverse sine function. And then the first one is more complex, that's why we replace 1 minus x squared as with the u, and then we just take a du over dx to replace x dx. So that's why we got the more simpler form. So using this simpler form, you can get the answer. Okay. Then you replace the u with our original x equations. Then finally we got this answer. Okay. So this is a little bit. You already learned how to do this one from your previous course. But I just want to remind that, so that because we sometimes use the integration and a lot of deliberations for dynamics course. Okay, then let me move on. Number 7. So So number 7. We know the equation. Okay. So I want to find dy over dx and the second derivatives. Okay. Okay. Right now, this function. If you rearrange this function so that you have the y is equal to something, it's a little get complicated. Okay. So dx over dx, how do we find those kind of delimitations? So in this case, we have this function. Okay. So we just take a derivatives directly from this equation. So what I mean by that is, okay. So let's just take a derivatives of dx. Okay. Like that. Okay, so we just take a derivatives on both sides with respect to x. So if you take a derivatives, the whole term, regardless of the left or right term with respect to x, what would you see? So this one, okay, so this one is 2 and 3x squared. Okay. And how about this one? So how do you find the y squared over dx? So at least we know that on the right side will be 0 because 7 is constant value. So how about the second term? So you know that so right now we want to find this one, right? So I want to use the chain rule, so which means 3 dy squared over dy and dy over dx. How about that? So in this case, we know that the y squared over dy is just 2y, okay? And then this is dy over dx. So that's why this one becomes 6y dy over dx. So on the left side is a 6x squared. This 6y dy over dx is equal to 0. So the 6 is cancelled each other. So dy over dx is equal to x squared over y. If y is not 0. Okay. How about the second derivatives? So the second derivatives is 2 dots. Okay. So this is square. And then right now this is the first derivatives. So if you take another derivatives, so which means I want to take another derivatives of this one over with respect to x. So how can we find this one? So just use this formula. Okay. So right now in here, this one is f and this one is a g according to our formula. So if you just use that, this is a y squared and f prime, so which means x squared prime. So x squared prime is 2x and y minus x squared and then g prime, so which means dy over dx. But we already got the dy over dx as x squared over y. So this is equal to 2xy minus x squared y over y squared. So if you just simplify these functions, rearrange nicely, then you see that answer. This is number 7, and the last question is this one. What is the derivatives of I unit vector over dt? So what is I unit vector? So unit vector, the magnitude is always 1. Then I direction pointing to the x coordinate. So actually this I vector is acts like or work like or behave like a constant value, because it has a 1 magnitude and direction is always pointing to one direction. That's why this one can be considered as constant. That's why di vector over dt will be 0. Okay, so this is the end of our homework 1. So I hope you received some help from my short video. And then if you are not sure about a certain part, please just review your previous learning from your linear algebra or deliberations, and then please make sure that you clearly understand how to do the deliberations and integrations, because we frequently use deliberations or integrations for dynamic course.